Welcome everyone to the interactive webinar about life cycle analysis. Today, our webinar will take approximately 1.5 hours, and we will try to guide you through informative and also interactive activities to learn more about what is life cycle assessment and, in other words, analysis. At the beginning, I would like to give a word to Annette to introduce you a bit more with the project in which word we are creating this webinar.
Thank you, Laura. Yes, hello, all participants. I'm very happy to see you all here. My name is Annette Grunberger. I'm representing Green and Smart Technology Cluster. And as I told, I'm very happy to see you here in the closing event of the project Knowledge Transfer of Life Cycle Assessment and Footprint Analysis in Baltic Sea region. This project is supported by Nordic Council of Ministers, and this project is implemented by 3 partners, by us, Green and Smart Technology Cluster from Latvia, by Cleantech Estonia from Estonia, and by What If Institute from Denmark. Thank you, and I will give back floor to our today's experts.
Yes, today we are very lucky. It's been a very interesting and nice journey to work together with our 2 partner countries. And now I will introduce you with the experts. My name is Laura Grundmane. I am representing Impact Hub from Liepāja, and I am a project manager of Science and Innovation Center Development in Liepāja city. And today, I have also joined with me here, Nicolai. Word to you.
Yes, hello everybody. Good afternoon, and calling in here from Copenhagen. Happy to see you all on the screen. I'm from the What If Institute. Basically been working with this topic, the topic of the day, for the last 20 years. So hopefully I can share some of my insights with you guys. Over to you, maybe, Katarina.
Sure, thank you very much, Nicola. I'm also very happy for being here with you today. I feel that from the first webinar, it has been 1 day, but it's almost 1 month for the footprint analysis, and I'm glad that we're going to do today the LCA assessment. And I'm Katarina, and I'm working in Cleantech Estonia as a project manager. And today with me is also my colleague Karl from Cleantech Estonia. So Karl, the word to you.
Yeah, thanks a lot. So yeah, hi from Tallinn, Estonia as well. I'm part of Cleantech Estonia, as well as co-founded a few cleantech startups where I've also done the initial, at least the LCA analysis, and looking forward to see if we can teach a few methods to you guys as well who are here.
Thank you, dear expert. So now, before we begin, I would like to ask you a question. What is life cycle analysis? Now, in the chat, there will be a link, and I would like that you could share with me your thoughts in one or two words, since we are many participants, to see what do you think life cycle analysis is. Just give me a second and I will share my screen. So for those who will write their answers, we will all see them. So maybe our experts can also write something to give some maybe clues. Okay, I was worried it's not working, but it is perfect. So I see here hopping up environment, sustainability, life, energy, use start at the end, understanding the product. Yes, we are getting closer. Oh, green energy. Oh, more ideas are popping up. Evaluation method, complex study about environment, nice. Recycling. Wonderful. Those of you who maybe haven't before heard about life cycle analysis, don't be upset. Today you are here to find it out. So the next time when this question will pop up, you will be sure that you are ready to type in several suggestions. And we see understanding the product. Yeah, wonderful. I think that you are very knowledgeable, and actually you already mentioned many good ideas, and you are absolutely right. Life cycle assessment is a methodology where we are understanding, or in other words, assessing environmental impacts that are associated with all the stages of product's life cycle, or either it can also be a service or a process. I am missing one slide, but I wanted to share with you that when we have when we are having a product, we have to also look at it that we started with the resources. So for example, when we want to make a pen, at first we need to understand from what do we make this pen? Is it made out of plastic? So probably we need oil. What kind of filling does it have? Then we need to think about how we produce this pen. Then how do we distribute it? How do we actually get it to our consumer? Then we need to think how we will use. Do I need an extra ink, or can I change its packaging? And then in the end, will it go to the landfill, or am I able to actually recycle it? So all the products and services are having their environmental impact, no matter how significant or small or big it is. It can occur on different levels, on the local, on regional, or even global, or all together. So to be able actually to measure them and to understand how can we improve our products, we need several standards. In life cycle assessment, we mostly use ISO 14004. I know that this part is very boring, but you need to know these things if you want to use them in your business. When we speak about life cycle assessment, we also need to think, what do we benefit from? Because today we want to give you an overall idea, how can you use it, what it is, but it's also important to look at the whole picture from the above. So most of the times we need it because we want to improve our product development. We want to know where it comes from, what's used in the product, also in the supply chain. For example, we want to evaluate our suppliers, where are these components coming from, how they are created, what kind of impact do they make, and also we want to improve our sales and marketing, and as well we want to think about our strategic management. And here is my slide that was that disappeared. I have a question to you all. How many t-shirts do you own? Can you write me in the chat? Think about it. How many do you have in your wardrobe? Oh, I see 134.
Maybe 50.
Okay. Those who can, don't be shy, bring it on. $44. Nice. So we can see that we have different importance for t-shirts in our lives. For some, it's just 1, 2, 3. For some, it's 50, and maybe you can change for 2 months straight every day new t-shirt. Why not? We humans, we are cultural beings. We like fashion. We like through our outfits, we like to show our characters and the things that we like. And it's really hard to judge ourselves, right? But most of the time, these t-shirts, they come easy and go easy. Oh. So have you ever thought how environmentally friendly is the t-shirt that you have just bought? And where does it come from? Or where or how its life will end when you will not use it anymore? To do so, I would like to show you a short story from Angel Chang. Okay, so I think the final question is quite nice, right? At the moment, we are owning 2, maybe 3, maybe 40, but how much of the t-shirts we actually own in our whole lifetime? Let me just go back to the presentation. Sorry. I have one small okay, and I am back. So, as Katrina already mentioned before in the previous session, we were speaking a lot about our footprint and how much we leave behind us. As we already saw in the video, we learned that each stage of the product life cycle is creating an impact on environment. In this case, as you can see in this footprint, it's calculated, the impact is calculated in kilos. Also today, we will be looking at 4 steps of life cycle assessment. So the first one is that we have to aim for the goal and find the scope. Then we have to look at the life cycle inventory, the impact assessment, and how all of 3 stages are interpreted between each others and our product. So when we look at the goal and the scope, it's very important that we at first choose one stage of the product life cycle, because when we will start to look at each and one of them, it can be a bit confusing and a lot of information. As you already saw in the video, when we are harvesting the product, we are using for the cotton, we use a lot of chemicals and pesticides. When we are shipping our product, we need a lot of different transportations because possibly we are moving it across the world. And also when we are selling our product, maybe it's coming in extra package, or it's having an extra hanger, or it's packed in another bag. So all these stages are having extra impact. So we need to be sure, for example, what do we want to measure and what kind of impact we want to look at. Here, for example, when we see the inputs to make for example, a t-shirt, we definitely need the soil, we need water. We also need pesticides, because when we have a very huge land of cotton, it's a very big possibility that this cotton field will be threatened by different insects. And if we want to make that our profit is going well, we need to ensure that we can make enough cotton for let's say amount that we are planning to produce. And also we are using synthetic fertilizers. But all these inputs can come into different outcomes that life cycle inventory is looking at. And for example, it can be the loss of the wildlife, the water pollution, and as well as soil degradation, because we are using a lot of chemicals. So we need to understand what data exactly do we need and how we will measure it. Impact assessment, for example, is looking more closer, and it's summing up the categories that will the impact will create. For example, as I already mentioned, the synthetic fertilizers are calculated in nitrous oxide, and it's 3 times stronger than CO2. So for example, as already said in the video, if the production of the t-shirts are causing up to 10% from green gas in total of the total planet's green gases, it's eventually easy to understand that it's a big problem. And then in the end, when we are interpreting this data, we need to understand that we need to measure how high are our emissions, how our product is compared with the other products, how we can improve it, and how we can also improve these processes. Because we need to look at every stage separately, at the harvesting of the production of the process and distribution and so on. But now I would like to, I will give a word to Katrina that will explain you better the first part of our workshop. And we cannot hear you, Katrina.
Sorry for that. So thank you very much, Laura, for this great presentation and this great intro into life cycle assessment. And actually, I'm super happy that nobody left, because it's quite a lot of big amount of information, and I know that it needs a little bit time of digesting all these things. So basically, to recap a little bit more, and I like to do practical things. So we will take what we learned and put our hands into dirt and see we will try by ourselves the life cycle assessment for certain products. So basically, the reason that we do an LCA, we can say it from 2 perspectives. From the consumer perspective, to actually see and understand if the products that we already use are environmental friendly, but also for the companies to understand what is their impact in order to create more environmental friendly products or services or processes within their companies. We saw also in the video that the supply chain is mostly, we can break it into 5 different parts, starting with the material extraction. So are the main materials that we take in order to end up in the final product. In the t-shirt, we saw in the beginning the cotton production and what is required there in order to grow up the cotton. Then the manufacturer to actually take the cotton and have certain processes and make it the end product as a t-shirt. And then every time we don't buy t-shirts from a factory, right, we buy it from retail stores. It's how they're packaged and how they're transported from the factory to the retail stores that end up as a consumer to us when we use it. So we saw this nice illustration with the footprint that shows what are the emissions that are calculated while we're using a product. We are ironing it, we are wearing it, we are washing it, we're drying it, and how much effect does it have to the general emissions. And of course, we have to see in the end of life, how is this product, when we don't need it anymore, is treated. So these are the main 5 supply chain stages, and I want you to think like all the products that you use in everyday life are passing throughout this process, and what is actually needed, and how our choices are not so safe, let's say, or so innocent, and they are always somewhere hidden some emissions. So okay, I can. So here you see it in a better illustration, the example that we already discussed, and the one that we saw in the video. So with the red post-its, you can see the main things that are coming out of this stage. So the material extraction is the end product, is the cotton, But in order to create that, you need the farm, you need the land use, you need the water, you need pesticides and insecticides, also the machinery for harvesting, and this machine to separate the balls from the seeds. And then you get the cotton. And then it gets into the manufacturing with so many different processes in order to prepare the sleevers, in order to prepare the fabric. Then you have to dye the fabric, then you have to stitch it. And like we saw also the transportation going, you have like the fabric, but it's not the end product, then you have to send it to other countries. So the transportation, I could say that there's a very tricky point because it's more or less in each and every stage. However, in our exercise after that, we will see it only from the manufacturing to the retail transportation and not in the whole process. And in the end of life, I would like to mention that you see different options. So feel free to use also different options. That landfill could be one option, maybe not the best, but it's still happening. Buying secondhand could be also to trade this t-shirt that you have, to donate it, to reuse it for something else, or even to recycle it. And it's time for our examples and what you're going to do, actually. Annette will help me to divide you into groups, in different groups, and you will work in teams with the people that are here today. And you will work in different examples to actually see the process and the life cycle of each and every product. The first product that we have is a burger. It's after lunch, so you know, stomachs, maybe some of you are full, some other are empty, but you have to find out what is the life cycle of a burger. The second one example that you will work on is to find out the life cycle of an aluminium can of soft drink. Mostly we care about the package and not about the drink itself, so don't get into much details with that. A more easy example regarding the t-shirt. So what is the impact of one t-shirt in different life stages? And the last and not least is a diaper. In the picture is a reusable one, but we will focus, let's say, on the single one, single-use ones. And I'm gonna, Laura, can you stop sharing the screen, maybe? Thank you. So I'm gonna share my screen now and see how does it look. And I will share with you a link in the chat. So please open that link, and that link will lead you to what you see in my screen. So basically here. So we will have different groups. We will have some groups working in the t-shirt, some in the soft drink can, some in the diaper, some in the burger. I will just to illustrate how it will work. So you will open the folder according to which group you will be. You will see it when you have to join in the group. You will see the name of the group you have to work. And you will open an Excel file. According to which number you are, we have 1, 2, 3, and 4. You will join accordingly. And then, of course, you have the rights to edit. And then you will see that there are many Excel sheets. You will go now in the first one. And you will see there's 5 different categories. So we talked a little bit about that also before. You have also some guidelines here. And if you need help, please feel free to reach out to us because we are here to support you during that activity. So in the first stage, for instance, in the t-shirt, you have to identify which are the raw materials that are involved in the production process, where do they come from, and if there is need of land, seeds, fertilizers, water. I don't want you to get into the numbers, but to actually identify what are the main elements in each stage. In the second stage, in the manufacturing stage, how the goods are produced. In a factory, what kind of machinery is needed. Again, don't go very specific, but just try to brainstorm and think what are the main elements that this product from the raw material can be manufactured to give us the end product, and also the energy required for that. About the packaging and transportation, how do the goods get transported, either by the means of transport or from where, and how they're packaged. In the fourth stage, what are the resources that we use while the product is in use? For instance, we mentioned about the t-shirt that we need to iron it, we have to wash it, we have to dry it, and so on. In the end of life, what are the different practices that we are using, what are the different practices that we use in order to finalize, let's say, the product cycle, how we close this product cycle. Is it landfill? Is it incineration? Is it recycling? And so on. If you have any questions, please raise your hand and ask. I'm more than happy to answer. And Annette, are we ready with the breakout rooms?
Yes, we are ready. I can send our participants to breakout room.
Great, so you will have about 10 minutes to do that. So make sure that somebody is writing in the Excel. Make sure that you are all participating and brainstorming. And if you need help from us, please feel free to reach out. So see you in 10. I'm happy that I see more cameras on and consistent faces as well. So I would like to briefly hear what you have done. When I'm saying briefly, I'm talking about like less than a minute. Very fast, very concrete, and if you can share your screen as well. So normally I say to people, hey, who would like voluntarily? Today, no. Today I will be a bit strict. So I would like to hear from team number 2, the t-shirt. That was Walter, Daria, Elizabeth, Emily, and Karl as well, I see there as part of the team. Who would like to share what you have done?
I have it open here, so I can share the screen and see what's happening over here.
That's great.
All right, so basically in the material extraction phase, there is brought out that we have cotton from China and India mostly. There is a load of water, cotton dye, polyester, other fibers. Maybe some others have any additions, then you can write in the chat or something. From the manufacturing part, there is going some energy, oil. Well, that CO2 gets produced. Well, that's that will be in the next phase as well, calculated probably. And for transportation, this group or our group believes it will be by boats and ferry for sure. Probably they will be used as well by coal or oil, or and probably some plastic packaging or carton packaging. And during the use, so another water gets used, and washing powder, gel, you need heat and energy, and afterwards it's mostly thrown away. So there's not much to do with the textiles. It's not even very good for burning energy. So you have mountains and mountains of it. Yeah, that's in a brief way.
Thank you very much. And think like in the previous presentation about the t-shirt, we didn't mention it all the detergents, but there's a great input that we haven't seen before. So I would like to call team number 3, so the Aluminium kind of soft drink, that it was Heidi, the teacher from Denmark, that I don't see the name, but I can, Jonathan and Nili, yeah, if you would like to share what you have found.
Yes, I think Heidi will share her screen and maybe explain what she has found. We have found. Are you up for it, Heidi?
Yes.
Yeah. Yes.
I will share screen. So in material extraction, we thought that they use aluminium, oil, and plastic. Aluminium and oil basically is from the ground, and so we thought that it's like that. Then manufacturing, they used to produce them. They made them in factory, and they need to use a lot of energy. So to heating process, ventilation, they need to have a lot of energy, and to make them to ship, they need to use some chemicals to be cleaner. They usually transport by truck or ferry, because by airplane it's like impossible to transport cans. When we need to cool down the cans, and usually in shops they are in fridges. So we need to use energy to cool them down. And after that, most of the Europe, probably, we have recycling stations. So we recycle them. And that's the cycle. Thanks.
Thank you. That was great. Thank you very much. And the presentation was also very nice. And I think that it's sometimes a little bit tricky to find like how the package is actually produced when we mostly use it for packaging other stuff. Thank you so much. And I would like to move to the next team, team number 4, that they have the diaper. Karina, Katri, and Katrin.
Hi, I think I will present because Katrina has to leave soon. Can you see my screen? Okay. So for materials, we need plastic. We assume that we will need 2 types of plastic for diapers themselves, and then there should be a layer of cotton or cellulose. We didn't really know, and then some super absorbent that they are really absorbing, and then some adhesive and paper for those sticky bands to close the diaper, and then ink for prints, because the diapers are usually with some pictures on them. And for manufacturing part, we assume that there is lamination to heat everything together, packaging, heating, water for cleaning, ventilation, and electricity for all facilities. And transportation, we assume that the diapers are made in Germany and Poland, and they can be delivered by trucks. And for transportation, we will need wooden pallets, plastic for packaging, and cardboard boxes. And we didn't know any resources that should be used together with diapers, just baby itself. And end of life, there's only landfill, I think.
Thank you very much, Karina. And I think the best resource of all is the baby itself. However, I'm thinking other products that we might need to use together with the diapers, like that you need some cream, or you need some powder, or some wipes, and so on. So there are additional things that you need probably with that, and you can afterwards measure the impact. I just bring like some ideas there. Thank you very much.
Yeah, we discussed it, but then we thought you can go without any of them.
Also, yeah. That's true. That's true. Thank you so much. And I will move to the last team before we move forward to team number 9 and to see the burger impact with Ula, Unna, and I think Laura was also there.
Yeah, our team, I was working with, I think, Josephine, if she's still here or no. Then I think I have left out alone because 2 ladies were not responding, and I was chatting actually with Josephine. So we didn't really manage to work properly on the table, but we were step by step trying to understand actually what the burger is made from. And already the first component, bread, made us think about that we need eggs and milk and salt and weeds, and already these 4 components made us to think about how each one of them is developed and created. But we also spoke about, let's say, the fast food burgers and the big consumerism of them, and also, let's say, that you need to use a lot of, as well as, of course, transportation, but you also need a lot of devices for the cooling, because many times these foods are processed foods, so they are staying in the freezers. And sometimes we were also speaking about that it makes us wonder how it's possible that a cheeseburger can taste the same in America, in Copenhagen, and I don't know, in Bali. Yeah, it's like everywhere the same. So that this is also very big challenge. Yeah, that's it. We were just we had a good chat.
That's nice, and I think your conversation actually brought up how big is the cycle, and you just go to the fast food and take it and eat it very fast. It's like, okay, I want more, and there's nothing, something like very serious and so on. And Karina wrote once like, okay, do we crave burgers actually for Friday dinner? But if you say how many elements it is and from where they come and how it is produced, is it actually so innocent to eat it? I'm not sure. Laura, would you like to share your screen again? Maybe. And thank you very much for doing this great work. And this is the first stage of our today's workshop. So, but before I close it and leave you to Karl and Nicolai, I would like to mention that it's quite important to understand that there are so many different so many different models of seeing the product life cycle and the life cycle assessment. So today we saw actually, when Laura will share her screen, only one model of that it takes from the beginning, from the raw materials until the end of life. However, most of the companies are doing shorter ones, so from the raw materials until the moment it leaves the factory, because in that way they don't get into account any emissions coming from transport. So it actually shows that the product is innocent, but and everything is okay, but maybe not actually, if you consider how much it travels around the world to actually reach to us. And the third model that we can have there is the cradle to cradle. That is basically the system of circular economy that Nicolai will talk about soon, which it takes the whole circle and nothing gets into waste. So the end of life for one product is the beginning of life for other products. Laura, could we maybe have the slide? Or
sorry, Katrina, just a second.
I can wait.
Yeah, is this what you mean?
Yes, that's exactly what I mean. So I was describing before, basically we did the orange one from cradle to grave. So from the raw materials to the end of life. The shorter one that I talked, it takes from raw materials until the transportation, at the moment that it leaves from the factory. And soon we're going to talk about the cradle to cradle, that it seems to be the most eco-friendly, the most sustainable, and the one that our economy sooner or later will go. And with that, I will leave it there and close it. And thank you very much for taking and participating in that workshop from my side. And I will give the word to Laura.
And I will go to word to the Karl, because we don't want, let's say, to keep you more longer to wait. And here will come the real part of how exactly we calculate life cycle assessment.
Yes, indeed. So, hi everybody, let's get now a little bit more to the specifics. However, fear not, my friends, this is just an introduction to this field. And today's exercise, you don't have to get everything right. You don't need to get anything right, actually. But the main aim of this is that in the future, you already know where to find the information you need and to test this out. So we're going a bit more specific with how you actually calculate the footprint of certain products and materials. We are building on the previous exercise. So all in all, I'll do a 5-minute intro, then we'll give you 10-15 minutes for group work, and then we should go over 1 or 2 examples so that everybody would get their questions answered. So if you get questions, if I'm going too quickly, just hit them in the chat, and maybe Laura or Katerina can tell me or just stop me as well, since I'm looking at the presentation itself. But first, what does the CO2 even mean, and why is everything calculated in this way, at least in this analysis? So carbon dioxide is a greenhouse gas. It warms up the planet, but we have actually many more gases and materials in general. So in order to understand the impact of different things better, scientists around the world have calculated everything in relation to carbon dioxide. So in short, we can calculate everything in CO2. So we have one common measure to understand the impact of many things in together. It's not perfect, of course, but it makes things easier to understand. For example, methane equals 25 times the warming potential of carbon dioxide. But this is only gases. We can do it also for all kinds of materials. So we can extend this thought and find the impact of anything by mapping out energy use, materials, transportation. So we are going to use this exact kind of table in our exercise. So just keep your eyes on this focus for a moment. I will go through this and then everything else will be easy. And I'll show you some examples as well. So on the left, you have like unit of a material, what we are looking at. For example, 1 kilogram of wool from Australia. On the right, you can see 2 types of numbers that are color-coded, yellow and green. The green one is the main aim of today. So for 1 kilogram of wool, producing 1 kilogram of wool, it emits quite astonishing 77 or 78 kilograms of CO2 in the air. And sometimes this CO2 footprint is also, it's not so understandable to people. What people understand more is money, usually. So I also added this yellow calculation over here. This means total eco costs. And this is not usually included in the prices yet, but it means that for producing 1 kilogram of wool, how much should we actually invest in giving back to the nature itself? So for example, into the green energy or planting trees. So for 1 kilogram of wool, we should also calculate in 10 euros, basically, or 9.5 euros, so that we could actually be sustainable and invest back in the nature. But this is very good to calculate in addition, because in most of the prices in nowadays, you don't have like this cost written out so far. We will share the presentation afterwards as well, but it's important to bring out that a lot has been done already by scientists and experts. So we can do actually the research itself once we know where to look at. So here are a few links and even some easy online tools as well, impact forecast or IDEMAT calculations. And just as one important background information, once we get to the examples, is that there is this thing called functional unit. So it's easier to understand our processes and impact if we just don't think about the factory's overall footprint, but we think about what we actually produce. So for example, our unit is 1 t-shirt. We calculate everything like the water use, the energy use, the cotton use per 1 t-shirt. So then we can better understand what we are doing actually, or 1 kilogram of tomatoes, or 1 cubic meter of packaging material. So here's an example of, by using that previous table, that 1 kilogram of cheese, we can see it in the table that producing 1 kilogram of cheese, it emits actually 13 kilograms of CO2. But I want to buy from Italy 700 grams of cheese. So that's why I put these things together. So for 1 kilogram, it takes 13 kilograms of CO2 and 0.7 kilograms. So it's a bit smaller. I have to multiply it together and I get 9 kilograms of CO2. Next thing, I will look at the packaging. So we need a bit 100 grams of plastic packaging. 1 kilogram of plastic packaging is 1.87 kilograms of CO2. But since we need only 10% of it, then it's altogether 0.187. So we multiply it together. The same with some carton or some board, 200 grams. So I find the information for 1 kilogram of this material, multiply together and get this information. For transportation, it's around 2,000 kilometers from Italy. I can see from the data table that going by a truck, carrying 1 kilogram of, let's say, our cheese, then it takes this very, very small amount per kilometer. But once you start to add up and you think about how many trucks and kilograms people are moving, then it actually makes quite a big impact. But just for getting my 1 kilogram of cheese or this whole product, it actually, this whole journey emits around 10 kilograms. And it's not very in-depth analysis here, so it's actually probably more. And we can do the same thing. Oh wait, do I have questions over here? I'll check over. Okay, it's about the webinar itself. So one thing more about the eco cost, what I mentioned before. So how much would we have actually, what is the environmental impact, or what should we invest back in this? So I get here the same thing from the table I will show you very soon. You can see at the same time, you can see like what's the eco cost of this 1 kilogram of cheese. And it's for 1 kilogram, it's 6.5. I have a bit less since it's 0.7 kilograms. And I do the same, exactly the same calculation. I just find this information for 1 kilogram, and then I multiply it with the actual amount that I have in use. And I get that in the end, the total eco cost is around 4.5 euros. Do I have any questions maybe from you regarding this?
There is
Invest back, yeah, I see this. So this is basically, it means that currently we are just taking out from the ground and from our materials, we are just abusing the earth itself. And currently we don't have these eco costs involved in the products. So it's just the environment, like the economic aspects of it. How much do I get profit out of it? And nobody cares about like what actually happens with let's say the nature after we rip it apart. So this eco cost actually means that if we take something from the ground, or if we produce this kilogram of cheese and packaging, how much should we give back based on this 1 kilogram? How much should we invest back into the nature, basically? So this what it means, basically. And this is why it's not usually, so things should be priced much higher. Everything should be, and how can we invest back? That's a great idea as well. That should be actually in every corporate sustainability thing that, well, as we see as well, that in the near future, actually all companies have to go greener, and they have to be more responsible, and they have to be more transparent about their footprint, for example. So companies can do it by reducing their own footprint, or by investing, for example, into planting trees or green energy projects or something like this that would actually be like helpful to reduce our general footprint on the earth. So basically in the exercise, we will use the same groups. We have the burger, and I'll put a bit of a fun thing over there, or at least not fun, it's a reality check. That doing like one thing, it shows like a very small footprint, but actually, like for example, there are 6.5 million burgers every day done by McDonald's. There are 2 billion shirts in a year. There are 80 billion soft drinks in 1 year, and there are 30 billion diapers in 1 year produced. So I just put it in there. I will show you soon as well in the Excel file. So it will calculate it for you automatically once you find like the footprint for one thing. And again, you don't have to be very specific. It's just if you do even one calculation, then I am super happy, because the rest you can do whenever you find useful or needed. And here I will just ask you to calculate just a footprint or even one small calculation. And if you want, then we can do also the, or you can do also the eco cost of the materials. And you can calculate like pretty much anything. Like for example, let's say burger, you bring out like some bread, lettuce, beef. You can find all these in the database. I will show you. And therefore, I will show you these things. But I also put in this exercise in the sheet 2, where you have like the exercise itself. There is like this cheat table where you can get some information. I will stop sharing at the moment this page. And I think I'm at the moment you should be seeing the burger page, right? You can see a burger over here. Yes. All right. So here it's the same Excel as before. You had like here you had the exercise 1. Now you go into the sheet 2, and we brought out here basically a small step-by-step what you need to do, but it's very easy. Here is the same example with the cheese, like over here, and here it's your what you put here in some data, and in the below I even put for every group I put like some information. So for example, you can take this information from here. You can add here bread 0.4 kilograms, then what you need, for example, for one product. And now what you do is that you go into this sheet 3. You need to find bread's carbon footprint. And yes, it looks like a lot of numbers. There is a lot of numbers. It's horrible. But all you need to do is to press Control Find or Command Find. Then it pops up here, Find here. And I write here bread. And here it comes. So here it is, 1 kilogram of bread, rye or wheat. And you can see that in the green we have here the carbon footprint, 0.5 kilograms. So for making 1 kilogram of bread, it emits 0.5 kilogram of CO2. And on the left in the yellow, you have this eco cost. So for 1 kilogram of bread, we should invest back 30 euro cents into the nature. So I put here, take this 0.5. You can write this out at first, 0.5 kilograms of CO2 for 1 kilogram of bread. I have 0.4 kilograms of bread. So I just put this 0.4 kilograms of bread and then multiplied with 0.5 kilograms of CO2 for 1 kilogram of bread. So I don't have like the whole kilogram of bread. I have only 0.5 kilogram of bread. So I just multiplied to get this smaller number, let's say. So it's 0.4 times 0.5 kilograms over here. And then you get the answer for the bread. And then you go through the same thing with the lettuce, beef. A number in the end pops up over here. For example, you can put here then, what is it then? I put here, in the end, I will maybe get like, I don't know, 0.8 kilograms of CO2. And then the number starts to come here. And if I add here, I get, I don't know, for lettuce footprint is another 0.5 kilogram. So I start to get here the sum of one product and a footprint of 6 million burgers every day. So it gets quite heavy. Only just this small bread part over here emits in one single day 8.5 million kilograms of CO2. So you get to understand like the real data, what is happening around the world.
I think, Karl, yeah, perfect. It's time to do the workshop.
Yeah. But in the end, I think people will just do one calculation. Don't go through the whole exercise even. Just go with your team to understand how the one calculation goes with. And then pretty much we're good with this exercise. It was more of a point out to do it than to go through the whole thing. I guess we are pretty much all back here. We are going through the funnel of getting into the LCA expert. It started from 50 and now we are down to 15 experts, but this is the life. Not everybody will make it.
No.
Okay, but I think let's take one example maybe, and I heard maybe one interesting fact as well from the diaper business. But who do we have here? Heidia, are you over here?
Yes, I'm here.
Can you maybe, I don't know if you can share your screen or
Yeah, I can. This screen, yeah.
Yeah, exactly.
Okay.
So you had soft drinks, one soft drink, and at the moment you you got to the aluminium and sugar already.
Yes.
And I think like one of the important thing is to just recognize is that what is one can doing? It's like nothing, but what happens in a year? So these are like that 4 billions is actually kilograms of CO2 emitted only based on aluminum cans of aluminum and sugar.
Yeah.
This is something to keep in mind. Yeah. And eco cost, what we are not putting into the environment that we should be mitigating the whole situation. It's I can't actually count all the numbers. It's like a million, billion, so 15 billion we should be investing based on only aluminum cans, aluminum and sugar, what we are not doing at the moment. So it's just like a small example, but any questions from the teams as well? What was like left unsaid or got like had still like a question mark regarding the exercise itself?
Yeah, actually, I have a question.
Okay.
How we should do with the energy?
Energy, if you go to sheet 3, can you press Control Find and put there?
Yeah.
Yeah, you got to the energy and you got those megajoules, right?
Yes.
Is the unit, and then you go to the sheet 2 again, and you can see that okay, this is the megajoule. So you just multiply this weight or other unit. So this is the megajoule actually already there, and you multiply it with that kilogram of CO2 in the green that you had in the other number.
With this number?
No, you multiply this 0.009.
Yeah.
And you multiply this with that sheet 3. You put on the sheet 3 that energy green number over there. So this is for 1 megajoule.
The first one, right?
Yeah, that first one. Yeah, general industry, or if you are in you're in Latvia. I think there is no Latvia here, but EU 27. You can take, for example, the average of Europe's electricity. Yeah. And then you put there equals this, and then times the other number over here, this one. Yeah, very good. Okay. All right, any other questions? If not, then we are in a not to say hurry, but we have a super awesome presentation as well from Nicolai. So let's put these numbers into the trash bin for a while and think about more abstract and interesting things.
Thank you, Karl. I'm taking over, I guess, and I'm just looking for actually my slides here. I think time is pretty much over already, so So perhaps we just keep it really, really slight, and then actually we're gonna share the slides anyways with everybody. And now my computer actually froze for some funny reason.
I can help with sharing the slides.
Yeah, maybe that's a good idea since time is flying. I don't know where it's took off to. Thank you. Thank you. Thank you, Laura. So basically, I guess time is pretty much up. We already are above schedule, right? So, but I think we did the right thing, because the important thing really today was to give everybody a sense and a feeling and between their own hands, like a sense of how to really work with this, do the calculations and see the numbers behind and really see how does it work when you actually calculate these kind of things. And I guess it makes us all think, as from after today, really, what can each of us do, and what kind of stuff do we use? How many t-shirts have we got, and how many cans do we put in the fridge every day, so to speak. So I guess my presentation, instead of taking you through a long presentation in respect of everybody's time, let me just in a short version, like say 4 or 5 minutes, go through the main points of circular economy with everybody's, if I can get some thumbs up, if that's okay with people, then we will do that. So Laura, if you jump to the next slide, and you can skip this one and take the next one. I think we just also today learned, and the world basically the last few years woke up from climate change and CO2 to having been kind of a good thing to think about, a kind of religion, to actually being very, very serious for our economies and for our planet. Next slide, please. Thank you. So our historic way of thinking about resources, which we also touched upon today, really has been to extract the resource, to produce something, to distribute it to the consumer, to consume it, and then throw it out in the waste bin. What we really want to move towards, next slide, please. Yes. Is really, I guess we learned that this is not really a sustainable way to work. Without going into detail, I guess just from Denmark, we realized that if everybody lived like a Dane, we would need 4.2 planets really to keep running, simply from the consumption we have here in this country, which even call ourselves very clean. Next slide, please. This picture basically took myself in Nairobi just a few weeks back when I was there. I guess this is really the dump site we remember from our childhood in our country. This is still reality in many parts of the world. Basically, you see all the plastics, all the crap being just disposed in the most wonderful parts of nature. But even in Kenya, where I was even last week, people realize it has to change, and we really can change in terms of how we think about products not being waste but being resources, whatever it is. Next slide, please. And next one. And next one. Yeah, so really what I want you to leave with today is really the understanding of what's the difference between a linear economy and a circular economy. And if you just remember this one, I'm happy because time is flying. So the linear is what I just took you through, really producing, take, produce, consume, and waste. Then we moved over to recycling, the recycling economy, which is pretty good, better than the other one, really, where we take as much as we can, try to recycle it. Could be bottles, could be paper, could be so many things, and that's really great. But where we really see the big impact, the big change, is if you move into the circular economy, where we take and then we actually make, and then we forever actually keep the whatever product in the circle. So we consume, we repair, we reuse, we recycle, we make again from the same material, and so on and so forth. And even a product can go from one thing to another, can have many forms and shapes over its life. So this is really the essence of circular thinking, circular economy thinking. Next slide, please. So if you look at it, really, and this is just kind of an expansion of the previous slide, in every part of the product's cycle, you can actually think about how you even go about it. So in the production itself, you can think about using fewer resources, less water, less materials, be more efficient with your materials, and less heat, etc. Which even saves you money, so it generates increased income, better services, also as one really extending the lifespan. Instead of just throwing out, you actually have service to maintain, to repair the product, and so on and so forth. Collecting when the product can't be used more, collecting it at least for manufacturing, recycle it, reuse the resources, disassemble it, and so on into the end of the circle, where you actually start producing something new again. Next one, please. So if you look at it, this is not just religion, this is pure money. And this is the big misunderstanding very often for companies. So everybody says green is so expensive. That's nice to have, it's not need to have for our company. And actually, if you take the numbers, even only from material cost savings, you would really, at the EU level, be able to save billions, as you see here, and trillions if you look at the world economy. So it's really money also at the bottom line if you look at it from the company's side. So, next slide, please. Same goes really for CO2 emissions. Of course, the potential is huge in terms of saved CO2 emissions, up to 40%, 3.7 gigatons in 2050 if we do it, if we just decide to do it. Next one, please. This one we can skip because time is running. It's the same point basically, and this one we can skip also. This one also, skip it and skip it. You'll get the slides. So what does it mean in practice? And let's take the next one. I like to share at least one or two examples with you, because that's where things comes to life in our minds, at least for me, when I hear a lot of theory. So one wonderful, very simple but genius company here in Denmark basically is called Small Revolution. I like the company name even. But what they do is they take all the PET water bottles we all know. I saw, Karl, you just had a Coke. That's exactly the bottle I'm talking about here. And you take that, instead of throwing it or recycling it, the day you can't recycle it anymore, you actually crunch it and you produce the most cool design furniture out of it. So forever you will have the coolest product based on that exact bottle that you, after you couldn't reuse it anymore, you can sit on it and you can enjoy life on it. So that's just one kind of mindset where we see, at least in Copenhagen, company after company popping up with these little new cool ideas how to use somebody's waste into and bring it into a new life in cool ways. So making really waste cool, that's really the agenda we also see here. Next one. This is the same, so we can take the next one. Maybe this one. I love this one, and we should have time for this, and probably then we should summarize. So now I just showed you a small example from the Small Revolution company. If we have time, we could try to watch this video, and then I'll come and run it in a second.
In the city of Karl, in the heart of Denmark, companies and authorities are working together to solve some of the challenges we face today. Here, Nicholas and Microsoft aim to be the world's leading industrial simulator with a circular approach to production. Like symbiosis, we understand that local
I think the sound is a little funny.
reuse resources to create a shared value. The is the raw material of another company. Based on our life cycle assessments of all existing flows in 2050, we can
I'm sorry for stopping in the middle of the video, but I will try to do the magic quickly again.
No, I think we can just skip it and I can explain it. It's fine. It's fine.
I wanted to say that nobody noticed what I did.
Where you provide, share, and reuse resources to create a shared value. The byproduct of one company is the raw material of another company. Based on a life cycle assessment of all existing flows in 2015, we can confidently say that Kalundborg Symbiosis offers both financial and environmental benefits. One example is an annual reduction of CO2 emissions by 635,000 tons, thanks to the partnership. Our mission is to act sustainably through the long-term responsible use of resources, in balance with economic, environmental and social considerations. We aim to connect all streams in Kalundborg Symbiosis and reach full resource utilization. We will continue to renew the partnership by identifying and attracting new members. And lastly, we will promote the symbiotic mindset and inspire others to be part of an industrial symbiosis.
Thank you. So what this example really shows is that one, as I guess the main learning here, one company's waste becomes somebody else's product or resource. So in this case, you have medical companies producing insulin and other medicines. They create a lot of heat, and that heat, instead of just letting it go out of the drain, they let that heat over to another company that really needs a lot of heat, even for the city itself. So this is basically a city in Copenhagen with 50,000 inhabitants. And if you drive around in this city, you actually see what you see in this picture, which is just an illustration, of course, but you see pipes, you see companies next to each other who are located there just because the resource from one becomes the waste from one becomes somebody else's resource. So it's pretty amazing life example of how we can actually do this. So the hot water even goes into another company from others. Waste materials becomes products for other companies here. So if you come to Denmark, call me and I'll take you, and you will enjoy really a live example of how it can be. I guess a disclaimer is that it takes time, obviously, to build this up, but it's a mindset and it's possible. Next slide, please. This one, I think we shouldn't go into that. Also, I think the point has landed with everybody, but just in the short version, at least, this example is about really taking again some sludge or some dirt you can call from the water, turn that into fertilizer, which then becomes the resource for the agriculture and for the food consumption, which again then leads out until water, which again becomes, extracted, which again becomes fertilizer, etc., etc. So extracting nutrients from wastewater, instead of just considering it wastewater, there's so much, even in something as unsexy as wastewater, there's a lot of business, there's a lot of resources in that. Next slide, please. So I guess we are reaching the end, and if there's any questions to this slightly quick presentation, it's all good. But I guess questions can even be raised to anybody in our project team after this this journey today. Thank you.
Thank you, Nicolai. In the end.
Thank you very much, yes, for the very inspiring final words that sometimes even the biggest mess can be a resource. Thank you everyone who is still here with us. It was really nice to work with you also in the small groups and to talk with some of you. Our as already mentioned before, the organization contacts are also in the Facebook link even, so you can find the organizations if you want to know more about what they are doing and working on and what kind of projects they're working with. And we all are open, yes, to any questions if you want to contact us. I see that it's we have left 4 minutes. If there is any final questions, you can ask them now. If not, we thank you very much for your time.